Okay, ladies and gentlemen, here we go. This is handout 1.15, and we're talking right now about converting from standard form to slope-intercept form. So, to show you, just remember we have to memorize these forms, and one of them is slope-intercept form. Okay, and that's y equals mx plus b. The other form of a linear equation is standard form, and this is what we got into last lesson, and that's ax plus by equals c. Alright, so I'm going to take you through this handout here and talk to you about some basic concepts. Number one, make sure that you're memorizing the equations, and number two, make sure that you are reading every bit of the detail of each of the problems. Alright, so it says here, I'm going to go into problem number one. I'm going to walk you through this one, and then problem number two here in 1.15. It is basically the same problem, and you're going to notice some things that are going to happen. All right, and I want you guys to go ahead and do those problems. So it says you are tasked with helping plan a school dance. You expect 110 people to attend the dance and need to provide seating for each person. So I'm going to go ahead and underline 110 people. And it says tables come in two different sizes. Right, so odds are you start reading these things enough, you understand that we're talking about table size. Those are going to be the variables that we're talking about. Okay, so smaller tables can seat 2 people, larger tables can seat 4 people. It says write an equation that describes the relationship between the quantity of small tables and the quantity of large tables, assuming exactly 110 people need seats. Alright, so when they say assuming exactly, that just means that it has to equal whatever your solutions are for the number of small tables and for the number of large tables. It has to equal exactly 110. Okay, so with that being said, any solution that you have for the number of small tables and the number of large tables is a solution, and it will fall on that line. Okay, so we're going to create a linear equation. Right, so let's first start off by defining the variables. Okay, so let me, just for sake of ease, I guess, I'll call S the small tables. And I'm talking the number of small tables. And I'll call G the large tables. I didn't call it, for me, and it doesn't matter what you call it, but I called it G because sometimes when I write an L, it looks like a 1, so I don't want to get those confused. Okay, so I just picked a different variable. Okay, so if S is the number of small tables, it says each small table, okay, will seat 2 people. Each large table will seat 4 people. Okay, so the number of small tables that I have, if I have one small table, then it will seat 2 people. If I have 2 small tables, it's going to seat 4 people, and so on and so on. All right, so 2S would represent the number of people that are being sat at a small table. Okay, so 2S is just a S is you don't know the number of tables that you have. Okay, so I'm going to say 2S plus, well, the other one is 4 people. So the large table seat 4 people. Okay, and the total number of people that need to be sat are 110. Okay. All right, so it says graph the line for the equation you wrote in part B. Label your axes. All right. So let's say just for ease of use here, the first one I'm gonna write that one as the horizontal axis. Okay, so we'll call that S. All right. And we'll call the vertical axis right here, we'll call that G, the number of large tables. Okay, so I have to label the axes, and then what I need to do is I need to come up with a, some sort of domain and range here. Domain and range, or how far do I need to go in the G direction, the vertical direction here, and how far would I need to go in the S direction. Okay, so from the last lesson we understood that if we just plugged in 0 for one of the variables, we can solve for the other variables, and if we just had large tables or we just had small tables, we could figure out the number of tables that we would need. Okay, so what I'm going to do here is I'm going to figure out what I would need for just looking at small tables. All right, if I just have small tables, I don't have any large tables at all, I'm going to go ahead and state it as G, the large tables, is going to equal 0. Okay, so I'm not going to have any large tables. I'm just going to do it with all small tables. So let me figure that out. So I'm going to write it out as 2S plus 4 times 0 equals 110. So I know that anything times 0 is 0, and anything when I add 0 to anything, it just is that thing. So I'm left with 2S equals 110. And then what I'm going to do is divide by 2. Now I have to get really good at doing using inverse operations, right? So I know that 2 is multiplying 2 times S, so in order to isolate S and get S by itself, I need to divide both sides by 2. And just always remember that what I do to the left side I have to do to the right side. So S is going to equal 55. Okay, 55 what? Well, 55 tables. I might write that down. Okay, so this right here, somewhere around here, or anywhere like in this region right here, that's where 55 should land. Okay, so if I'm looking at these tick marks right here, or these squares, I might look at that and just say, well, 5s, just go by 5s, right? And let's see where I get to. As long as I'm somewhere around here, I'm good no matter what I do. Okay, so I could go by 1s, but I'm not probably going to only get up to somewhat, like 20. Okay, so I can't go by 1s. I can go by 2s. All right, then I'd have to have like 27 of those, because if I divide 55 by 2, I'd have to have 27 and a half, right? Okay, so I'll just write them out as 5s. Okay, and in this case right here, let's just do that. Let's go 5, 5, 10, 15, 20. That doesn't work. Let me just write them as, let's go 10s. Write them every 2 is 10. I'm doing the same thing, but I'm just writing it as 10. a little tick mark in each one. Okay, and that would be 60. Okay. Yeah. So I could, you know, maybe I could have done that. If I'm looking at this right here and I'm working it out, I probably wanted to get it more around here. Okay, so what I might do, instead of writing it out by tens, maybe I can write it out every time I put a 10 here. Maybe I'll write it out as 5. Okay, and I'll see where I get to. Okay, so it's you know, what I'm doing is, you know, a little guess and check. I want my 55 to end up somewhere over there. So if I write that out and I say every 2 squares is 5, so I'm going to say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. That looks pretty good to me. I think that's perfect. Okay, so this represents the number of small tables. Okay, so I know that 55 tables is when I have 0, I don't have any. Remember, this right here is, this axis right here is the number of large tables. Okay. All right, so I have that, and I can put a point right here. So 55, and that point would be 55, 0. Remember, if we're graphing it, it's 55, comma 0. The horizontal comes first, and then the vertical comes second. So next thing that I want to do is I want to look at this now in terms of saying that I don't want any small tables. So I'm going to say S equals 0. All right. So I'm going to write it out as 2. Sorry. Yeah. Let's see. Whoops. 2 times 0 plus 4g equals 110. Okay, so what I did here is, looking back up at that same equation, that equation that I wrote out earlier, right? I got this equation. What I'm doing here is plugging in a 0 in place of the s, because I'm saying that I'm going to look at it to find the number of tables that I would need if I'm just using small table or large tables. Okay, so that 0 doesn't mean anything because it's 0. It's 0. Adding 0 to something is just whatever it is. So I get 4g equals 110. I divide by 4, and I get g equals 27.5. Okay, all right, so now what I'll do is I'm going to look at this and, all right, well, maybe I can say every third one. We'll just check that out that way. Every third one represents 5. Okay, so 5, 1, 2, 3, 10, 1, 2, 3, 15, 20, 25, 30. And 35. Okay. So 27.5, well, 27.5 is right here, so 1 and 2/3 would equal one of the tick marks or whatever. So, and we'll say it's 27.5 is right there. Okay. 27.5 wouldn't that be halfway between 25 and 20 and 30? Yeah, that'd be 2.5 above, 2.5 below, right? Okay. So now I can go ahead and take out my straight edge, and you can do this. I found this little method here. You can do this directly on your computer screen. You have it, just place a little straight edge on it and draw your line. Alright, so there you have it. Now let's answer the rest of these questions, and I'll let you do problem number 2. It says find both intercepts. Well, guess what? You know, we just did. We just found our intercepts right here. Okay, so in this case right here, our we'll call it S-intercept, because S represents the small tables. S-intercept is 55. Okay, the G-intercept, okay, G is my, right here, G is my large table axis. My G-intercept is 27.5. Okay, so I've already done it, and that's, you know, that's the work for that above here. So I can go just point an arrow to that. Good idea to do that, just so that I know, you know, if I'm grading you or your teacher's grading you, they know where the work is. Okay. All right. Now it says, what do these quantities represent in context? Okay. All right. So, do they make sense, and why or why not? All right. So in context, there's lots of things that you could say. I'm going to look at this from what are these tables, what do these intercepts mean in the context of the problem? Well, we always start back at how many people do we need to seat. We need to seat 110 people. Okay, and I'm going to say let's talk about the S-intercept. So to seat 110 people, you could use 55 small tables only. Okay, so only small tables, use 55 of them. Okay, so to seat, now I'm doing it the other way, doing it for the large tables. To seat 110 people, you would, maybe would is a better word for that, would use 20, and we would say 28 large tables. Okay. Do they make sense? All right, well, definitely if I'm seating 110 people, I could use 55 small tables, right? And that definitely makes sense. Okay? So it definitely makes sense that 55 small tables could be a solution to that. Now when we get to the large tables, you know, I put in here 28, but the actual answer is 27.5. So you couldn't have 20, you can have half a table. You're not going to have half a table for that. So that in that way, it would not make any sense to have a half of a table, but we would have to use one more table. Okay, so I would say yes, they do. Yes, small tables make sense. Large tables would need another table. So guys, as I'm writing this to you, I don't want you to write down my words verbatim. That's my interpretation of what this is, and there is an amount of interpretation that is necessary for this. But to get to tell your teacher, to tell me, your teacher, or your teacher, whoever you have, that you understand this problem, you're going to need to have gonna have to prove that you understand what's actually going on with the intercepts, with the s-intercept and the g-intercept. Okay, so make sure that you are, as you're reading it back to yourself, it's easy enough for just a random person you pull off the street to explain it to them. Okay. All right, so it says here, you order 24 small tables and 15 large tables. Will this seat exactly 110 people? Okay. So 24 small and 15 large. It's very simple. All I have to do is I have to plug those into my formula. I'm going to use that formula again. So remember, my formula was 2s plus 4g equals 110. Okay. So I'm going to say s equals 24 and g equals 15. That's what that says. And let me go back in and I'll just erase this. And instead of the s, I'm going to write 24. Okay. And instead of the g, I'm going to write 15. Okay, so this ends up being 15 times 4 is 60. This is 24. 24 times 2 is 48. So 48 plus 60 equals 108. Okay, we needed 110, so it will not fit exactly. Okay. Now, what would you guess that you would need to do? Well, if tables see two more, well, I need two more. I need another table, another small table. 25. Okay, 25 small tables would work. Okay. 25 small tables and 15 large tables. All right. So now it says write the equation you found in part A in slope-intercept form. Okay, so show all of your work. All right, so we found the equation to be 2s plus 4g equals 110. So slope-intercept form is, remember, it's y equals mx plus b, and usually your second variable we're going to call, let's just call that one the y variable. So we'll say that g is going to equal y. All right. So that will be the reason why I'm saying that is because I want you to solve for g. Okay, you're going to solve for g and you're going to make it look like this. Whoops. Okay. All right. So how do you solve for g? Well, the first thing that you have to do is you recognize, okay, there's the variable that I need to solve for. My goal is to get g by itself and everything else on the other side. Okay? So all stuff on the other side. So what I need to do is I need to use inverse operations. And inverse operations just means if I'm adding something to that variable, then in order to get rid of adding it to that variable, I have to subtract it. So what am I adding to 4g? I'm adding 2s. All right, so in order to get rid of 2s, I'm going to subtract 2s. I'm going to subtract 2s from both sides. Okay. very important that what you do to the left side, you have to do to the right side. Okay. Alright, so now I'm going to move this answer right up here for you. And it's going to be 4g equals, we'll call it, I'm just going to put the negative 2s first. Doesn't matter how I write it, but I'd like to, slope-intercept form would have the variable term come first. Okay, almost there. Now I know what 4g is, so, but I don't want to know what 4g is, I just want to know what 1g is. So what I'm going to do here is divide by 4 on both sides. Now here's the thing, when I divide by 4 on both sides, I'm not just dividing the first term, which is negative 2s, by 4, I'm also dividing the 110 by 4. Okay? So that 4 needs to be distributed to both the 2s and the 110. Okay, so now g is going to equal, so I'll write it, I'll separate them and I'll say negative 2 over 4s plus 110 over 4. Okay, well, this 2 over 4 reduces to 1/2, so g is going to equal negative 1/2 s. And we found earlier that the b value is going to be our y-intercept, right? And our y-intercept was 27.5. We already did that division, 110 divided by 4. Okay? So that's our equation in slope-intercept form. Okay? So now for number 2, it's talking to you about basically what's you're going to notice that it's going to double things, and what's going to happen when you double things. Well, they're going to double the people, and then they're also going to double the amount that you have that a small table will seat and the amount that a large table will seat. So apparently they got bigger tables for each of them, right? So you're going to do the same thing that you just did above, okay, for problem number 1, for problem number 2, okay? And then just answer those questions to the best of your knowledge, okay? All right, on to problem number 3, okay? The problems for my class, the problems that I'm circling here, are problems that I'm doing for you. You just understand, make sure that you're understanding them. I expect you to learn it and know it, but I'm also helping you out and giving you basically the notes for it. Alright, the squared problems are problems that you do. So now we're down to number 3. Okay, I'm going to do number 3 for you. Okay, I'm going to talk to you about number 3. Consider the linear equation 2x plus 3y equals 7 given in standard form. So this is standard form. It says fill in the blank in each of the following equations below so that they have the same solution set as the equation 2x plus 3y equals 7. For the last equation, create an equation different from those given that will have the same solution set as the others. Okay? Alright, so it's all based on this right here. Okay, now, very important to learn and to know multiplication tables, right? So I need to know that if I look at 2x plus 3y, what looks familiar when I go from 2x and I go to 4x, and then I go to from 3y to 6y, and there's a negative there. Okay, what pattern do you see in those numbers? Well, I see that 2x to 4x, I just multiply by 2. And to get the negative, I multiply by a negative 2. Okay? So I found that, okay, negative, if I multiply 2x by negative 2, I'm going to get negative 4x. If I multiply 3y by negative 2, I'm going to get negative 6y. So I'm going to multiply negative 2 times the quantity 2x plus 3y equals 7. Now, why did I write the equals 7 over there? Because if I do it to the left side, I also have to do it to the right side. So basically what I'm going to do is I'm just going to multiply that thing out, okay? So I'm going to multiply it by all three and keep the signs or the alternating signs, right? So negative 2 times 2x is negative 4x. Negative 2 times times positive 3y is negative 6y, which is what you get right here. And the last one, if I do it to the left side of the equation, I have to do it to the right side. Okay? Alright, so start you off with that one. Okay? You do 2, or the second one. Okay? For this one right here, if you look at this third one right here, 16x. How did I go from 2x to 16x? Well, I think what's happening is you're multiplying it by 8, right? Because look, what happens when you multiply 7 by 8? Don't you get 56? That's why it's important to know your multiplication tables, right? Very important, right? So 2x plus 3y equals 7. Same idea. I'm going to distribute it. Okay? So I'm going to say 16. And how did I get 8? Well, I looked at 16 and I looked at 2, 16 and 2, and I said, well, how do I go from 2 to 16? Well, I multiply by 8, right? 2 times 8 equals 16. How do I go from 8 to 56? From 8 to 56, I multiply by 8. Okay? So if it works for both of them, then it's going to work for the one in the middle. All right? So I get 16x plus 8 times 3 is 24. Y equals 56. Okay? So that should be 24. Okay? Now for your for yourself, this one right here, now you're missing 2 of them. You're missing this one and you're missing this one. What happened to go from 3y to negative 15y? What did you multiply 3y by to get negative 15y? Figure that one out. Okay? And the last one, it asks you to create an equation different from those given that will have the same solution set as the others. Okay? So when they say same solution set, it means they're the same line. They're the same. It's the exact same equation. It's just a multiple of that linear equation. Okay? So that being said, if it's a multiple, you can multiply this equation right here by any number. Multiply every coefficient and every constant by the same number. Maybe it's 10, maybe it's 20, maybe it's 15, whatever you choose. But multiply each term, okay? 2x, 3y, and 7 by a certain number, and then just write those numbers in there. Okay? So I'll have you guys go ahead and do that one as well. Okay. Alright, so this one here, it's the same problem as above. I'm going to give you a different example, and I'm going to solve a different example for you. But you know, let's say that we have I don't know, 5x plus we'll say I'll just say 3y equals 11. Okay, so I just made up a different one. What they're asking you to do, it says fill in the blanks for the following standard form equation so that it will have the same solution set as the equation 2x plus 3y equals 7. Okay, so the blanks go like this. It says some blank x plus blank y equals 1. Alright, so opposite of what we were talking about earlier, how we found, okay, what did I multiply the 3y by to get the negative 6x? I multiplied it by a negative 2, right? And that's what I did. I multiplied it out. Well, right here, what do you multiply 11 by to get 1? Well, what do you multiply 11 by? 1 over 11. Okay, so if I multiply, or we could also say divide, I could multiply this by 1 over 11, and that will give me 1. Well, guess what? If I multiply the right side by 1 over 11, okay, and by the way, multiplying by 1 over 11, okay, that's the same thing as dividing by 11. It's just saying divide by 11. Multiplying by 1 over 11, the same thing as saying divide by 11. So I'm going to go ahead and multiply each term by 1 over 11. Okay? So if I multiply 11 by 1 over 11, I'm going to get 1. That's what I get right here. If I multiply the 3y term by 1 over 11, I'm going to get 3 over 11y. Okay? Whenever you multiply a whole number and a fraction, just multiply the whole number by the numerator. Okay? And if I multiply 1 over 11 by 5, I get 5 over 11. Okay? So here's the thing. Properties of math, that's what we need to know. If I multiply an equation by, both sides by the same thing, it doesn't change the equation at all. Okay, and that's an important concept. That's the one thing that we're looking for you to understand in this problem right here. So you're going to take the same skills that I just showed you right here, multiplying by, if you're trying to get 1, and how do you get 1 when you have a whole number? You multiply by the reciprocal, and then gives you 1. That's what we call the inverse of multiplication and division, right? So the inverse in multiplication gives you 1. All right. So it says now once you get this, it says to find the slope. Okay. So this one says find the slope of the linear equation. Okay. So I already have. I'm going to show you my example right here, and I'm going to show you my example so that you can take that and plug it in for your example for this problem. Okay. Which I think is going to be easier than this one, than the one I'm showing you. Okay. So in order to create slope-intercept form equation, what I'm going to have to do is get y by itself. Okay? So just like I did before, I have to look for, the other term that you're adding to the y term, and that one is the 5/11ths x, and I'm going to subtract 5/11ths x. Okay. These will cancel out, and I get 3y, or 3 over 11y equals negative 5 over 11x plus 1. Okay, I'm right there. I'm almost there. The only thing that I have is I don't want to know what 3/11ths y is. I want to know what y is. Okay, so how do I get 1 out of 3/11ths? multiply by the reciprocal. Okay? And if I multiply by the reciprocal on, I'll do it like I did up there, on both sides, then this part right here, that cancels out. That's going to give me y, right? Okay? So I'm going to undo that, crossing it out here. So I distributed it to this one. Now let me distribute it to that one. Well, I multiply by 3 over 11. Well, that will cancel out and this will cancel out, and I'm going to be left with a negative 5 over 3. Okay? X. Alright? And then I'm going to distribute that also to the 1. And I'm going to end up with plus just 11 over 3. Okay? And this is slope-intercept form. Okay? Alright, and I'll let you talk about this one. Will the graphs of the equations you created above have the same slope as just as what I already told you is that if you multiply, both the left and the right by, by the same number, then it's going to keep the exact same line in the exact same equation. The equation will be the same, right? It may not look the same, but it's going to be the same equation, okay? And if it's the same equation, then it's obviously going to have the same slope. Okay, guys, that is it. I'll let you guys go ahead and finish up the rest of those problems right there and answer those questions to the best of your knowledge for 1.15. Thanks for watching.